We have here, guys, is a smooth sphere of mass 4 kilograms moving with speed u collides with a stationary smooth sphere of mass 8 kilograms. The direction of motion A before impact makes an angle A with the line of centers at impact. The coefficient of restitution between the spheres is a half. Find in terms of u and A the speed of each sphere after the collision, the angle through which the 4 kilogram sphere is deflected as a result of the collision, the loss in kinetic energy due to the collision. Okay, so I'll read my own solution. Easier. Okay, so do what I always do. Draw a mini diagram of before and after. Okay, so that can be particle A, particle B, before, after. I need the visuals to get everything into my head. Now, here we go. Okay, so this one here is going at speed u in this direction here. Now, what I did there, guys, was I extended the u through the line. So I went like this. See that? So I extended its arrow further on, and then this angle in here has to be angle alpha because it's opposite angles. Okay, so found out that's alpha, and that makes this one u cos alpha, u sine alpha. Is that right? Now, after the collision, what happens? Okay, does it say? Oh yes, 8, the angle B, the second one isn't moving, so 0 in both directions. Okay, when two spheres collide, what happens to the second one if it's already stationary? What direction does it have to move in? When you join the centers together, there's a line. The momentum transfer takes place along this line. So because the second one isn't moving to begin with, what happens when the collision takes place? It goes straight to the right. Okay? And we're going to assume they both go to the right. And if they don't, it'll autocorrect with a negative answer. So we're going that this one is still going up at 0, but it's also going what's that word? It's going up at 0 still, but it's going to go across at a letter. We'll call that letter phi 2, because we don't know yet. We'll call this one phi 1, and then underneath here, what happens to the j direction? It stays the same, because remember I told you that the collision takes place along the centers, means your j speed is maintained. Okay. PCM, principle of conservation of momentum, m1u1 plus m2u2 equals m1v1 plus m2v2. Okay, so m1u1, anybody? It's 4, isn't it? So 4u cos alpha plus a times 0 equals 4v1 plus 8v2. Then cancel the that 8 times 0 goes out nowhere. Divide both of them by 4. And get v1 plus 2v2 ends up to be u cos alpha. Okay, that's very easy stuff, guys. All right. NEL, Newton's experimental law. Anybody remember? Minus E equals v1 minus v2 all over u1 minus u2. Do we know the E value? E value is a half. So, minus a half ends up to be phi 1 minus phi 2, because we don't know what phi 1 and phi 2 are yet. And then u1 minus u2. u1 is, u cos alpha minus 0. Cross multiply, minus u cos alpha equals 2v1 minus 2v2. There's your second equation there. Just reverse it around. 2v1 minus 2v2 equals minus u cos alpha. Okay. Now, we're going to have here, guys, we're going to bring this down, and we have a simultaneous equation using the equation A and B here. Add directly down, 3v1 ends up to be 0. v1 therefore ends up to be 0. So this means that this v1 equals 0 means that this one is now only travelling upwards. Okay. Now, I usually tend to solve. I don't usually tend to substitute in. I actually find it's just easier to solve the. I find it's actually just easier to solve the quadratic, or sorry, solve the simultaneous equation than substitute in most of the time. So, what I'm going to do here is I'm going to multiply by minus 2. Minus 2. I'll do it underneath actually. So I'm going to modify this equation here. Minus 2v1 minus 4. Actually, plus 4v2 minus 2u cos alpha. Then, just going to rub out the middle one. Add directly down. 2v2 ends up to be. Now, just give me 1 second.
It's minus 4v2.
Sorry?
It's minus 4v2.
Is it minus 4v2? Ah, you're right. Minus 4v2. There we go. Okay. Yeah, so that makes it minus 2v2 minus u cos alpha divided by 2. v2 equals u cos alpha. So u cos alpha all over 2. Sorry? Yeah, it is, yeah. Sorry, because both of them actually gave me the same answer. That's why it didn't ring a bell. So, minus 6v2, and so as I did then, both give me the same answer. 3u cos alpha divided by minus 6 of v2 ends up to be u cos alpha all over 3 over 6, same thing as u cos alpha over 2. Alright, so you have v1 and v2. Okay, so the great news is v1 and v2, once I have that, anything I've done here doesn't need to be used anymore. Okay, so that's all being used. Is that alright with that? Now, what we have next is the angle of deflection, isn't it? The angle through which the 4 kilogram sphere is deflected as a result of the collision. Okay, what is it deflected? Okay, so before it was going up at angle alpha. Everybody agreed with that? This direction here. Afterwards, it's only going directly upwards. So the black line is before, this is after. That makes that 90 minus alpha. 5 marks for that. Okay? Now, the loss of kinetic energy due to the collision. KE loss equals KE before minus KE after. Okay? So KE loss equals KE before minus KE after. Okay, so what is the kinetic energy beforehand? A half mv squared, so KE before, which is a half 4 times u squared, which equals 2u squared. KE after. Well, KE after is a half. So it's two different objects, isn't it? So a half mv1 squared plus a half mv2 squared. Now, guys, v1 and v2 technically aren't the ones that we got. It's just its overall speed. So if I have two components, if I have it going across a 5 and up a sorry, I'll do it easier this way. If I have it going across a 3 and up a 4, I have to get the hypotenuse and say it's a half the mass multiplied by 5 squared. So I have to make sure I have a hypotenuse in both cases. Okay, so as it turns out, we got lucky in this one. Can anybody explain how we might have got lucky? As in, each one only has one component, doesn't it? This one here only has a j component of u sine alpha. It has no I component, so we know that its velocity is u sine alpha, and we know that this one here is u cos alpha over 2. If it had an I and a j component, you'd have to do Pythagoras' theorem to find the hypotenuse and then use that as your velocity. Okay? So, what's happening here is we're going to have a half m. M is going to be the mass, which is going to be 4 times u sine alpha squared. Then it's going to be a half times 8 times u cos alpha over 2 squared. This is going to be a half times 4, which is going to be 2u sine squared alpha. Oh, sorry, yeah, u. And then this one here is going to be 4. Oh, sorry, it's going to be u cos alpha over squared is the same thing as u cos alpha over 4. So u, the same thing as, and that's u squared, excuse me. So when you square that out, you're going to get u squared cos squared alpha all over 4. When you squared that out, it would have been u squared sine squared alpha, and then a half of 4, which is 2. Then we're going to get 8 divided by 2 is 4. 4 divided by 4 cancels, and then you get u squared cos squared alpha. I went one step further. I divided the 2u squared into u squared sine alpha plus u squared sine alpha plus u squared cos squared alpha. I factorized out the u squared to leave me sine squared alpha plus cos squared alpha, which we all know is what, guys? And it is this here, number 1. So the answer is u squared plus u squared sine alpha. Okay, that's your K after. Okay. Now, still haven't finished off the question, have I? It's K before minus K after. So the loss in kinetic energy is going to be, what did we have before collision? We had 2u squared before the collision, and we had this much after the collision. So 2u squared minus bracket u squared plus u squared sine alpha. We're going to get u squared minus u squared sine squared alpha. Take out the u squared, and what happens next, guys? Can anybody tell me what 1 minus sine squared alpha is? I'm basically just changing it back, yeah. It's u squared cos squared alpha. And that's your answer.